Okay. I almost said something inappropriate back. Okay. Okay. Point C is at 2, 9. Under which reflection is C prime 9, 2? So for this one, it'd be best to just graph it out. Let's see. I'm going to draw a coordinate plane. Okay. 2, 9 would be 2, and then up 9, so it'd be about right here. So that's point C. And then 9, 2, which is C prime, would be out here and up 2. So C prime would be about right here. Then you need to figure out under which line of reflection could this be reflected. So reflected in the x-axis, well, if I reflected this point over the x-axis, it would fall down here. So that's not correct. Reflected in the line x equals 2, that would be a line right here. If you reflected it on the line x equals 2, it would land in the same spot. That's not correct. Reflected in the y-axis, that would be right here. If I reflected it over y, it would land over here, which isn't where it landed. And then reflected in the line y equals x. That's a diagonal line going up and to the right. If you reflected it over that line, yes, it would land in that spot. So the answer is D. Okay, number 2, name the image of KL under a reflection in a vertical line through point N. Okay, so we have segment KL. I don't know if it's better if I use a color or something. KL. It's saying a vertical line through point N. Here's point N. A vertical line would look like this. If you reflected KL over that vertical line, it would land on JM. So C. How many lines of symmetry does a regular 12 gun have? It is going to be 12. So for a regular polygon with a regular polygon, it would have all the sides the same length and all the angles the same length. And so you could just count the number of sides, which is saying it has 12 sides, to find the lines of symmetry. Which of the following figures shows a translation? A translation is when you slide a shape. I would say that's either a reflection or a rotation. So it's definitely not a translation. B, same thing. It's either a rotation or a reflection over a line. So not a translation there either. C, I can see it sliding in this direction. So therefore, this is a translation. And then D, it's shrinking, so that's dilation. But the answer is C, the translation.
So a secretary will message on Schoology without
I'm not stopping what I'm doing to check it though, Logan. Okay, number 5. Name the image of C, which is 6, -4, under a rotation 90 degrees about the origin. So for this one, you would pull the rule off the board. 90 degrees is -yx. So the rule -yx, and then you use that to transform the points to get +4, 6. We're getting there. Okay, number 6, name the image of point Z along the translation vector of 1, 7. So with a translation, this is your horizontal change and your vertical change, and you can add that to your points. So this would be -11 plus 1 and -6 plus 7. So you would get the point -10 and 1. So that would be C.
That's where you got 1 from.
Oh, this right here. The next one. Find the angle of rotation of a figure that's reflected in 2 lines that intersect to form a 66-degree angle. This is something that Ms. Boyso didn't include in her notes, but it's in the textbook. I'm going to quickly explain it. I don't know if I'll have it on the test or not. I guess I'll let you decide after you see it. It's saying you have 2 intersecting lines, 66-degree angle. It says a figure is reflected over both of those lines. So let's say you have a semicircle. It's reflected over this line, and then it's reflected over this line. And so it forms a rotation,
That is stupid. Makes no sense.
Okay, so it forms a rotation, and the angle or the degrees of the rotation would just be 66 times 2 every single time. Like you just multiply those degrees by 2. So it comes out to 132, and that is your answer. So for this, all you do is you multiply the degrees by 2. I don't know. It's an easy question. Should I include it or not? I don't know.
Yeah.
We'll see. Just include it. Number 8, point Z is at 4, -2 is rotated 180 degrees about the origin. What is the image of Z prime? The rule for 180-degree rotation is -x, -y. So you would get -4, 2. That would be B. Number 9, which does not describe a transformation that could be used to create the pattern shown? Okay, well, if I translated one of these shapes, like just slid it, yes, I could get it in the position of the other shapes. Rotation, could I rotate these shapes on top of each other? Yes, I could. Reflection, could I reflect them on top of, yep. Dilation,
Can't make it smaller.
you can't, they're all the same size, so didn't use dilation. What type of dilation occurs with a scale factor of 1? When you have a scale factor of 1, you're literally timesing the shape by 1. It's the same size. So it doesn't change in size at all. So it is not an enlargement. It's not a reduction. Glide reflection, that doesn't even make I don't even know what they're referring to there. Congruence transformation. Congruence means like they're the same shape inside. They're congruence. Congruent. So that is the answer there. How many lines of symmetry are in the figure below? Yes, it is 3. When you have a regular polygon, all the sides are congruent. You would have the number of lines of symmetry as the number of sides. 3 lines of symmetry. Next question, number 12. You're right, it is B. Stella carved an equilateral triangle that is 3 centimeters on each side of the pumpkin. And then she carved another equilateral triangle, which is 5 centimeters on each side. What is the scale factor that she used? Scale factor is the new one over the old or original. So you can take the side length of the new one, which is 5, over the old one, and that is your scale factor, which is B. Number 13, the line segment TU with endpoints, and it gives you the coordinates, is rotated 90 degrees about the origin. What are the coordinates of T prime? So even though there's 2 points here, it's only focused on point T. The rule for a 90-degree rotation is -yx. So we would get -1, 2 as the answer. 14. A point R with coordinates 3, -1 is translated along this vector and then reflected in the x-axis. What are the coordinates of R prime? For this one, I would recommend graphing it. It's a composition of transformations. You're translating and then reflecting. So for 14, I'm just going to use this graph paper here. And obviously you won't be able, you don't have graph paper in front of you, but here's what you would do. Point R has the original coordinates of 3, -1, so here is point R. It's translated along the vector -2, 3, so you'd go over to the left 2 and up 3. So this would be R prime. And then it's reflected on the x-axis. This is the x-axis here, so you'd reflect it over the x-axis, and you get R double prime is right here. Then you also need the coordinates of that, so it'd be 1, -2 as your answer. And so that would be C. For this one, you could use the coordinate rules, but honestly, if this was on a standardized test, you're not going to have those to reference, so it's best to be able to use the concept as well. 15, which of the following regular polygons has a magnitude of symmetry of 72 degrees? Magnitude of symmetry is how far you have to rotate it for it to land on top of itself. So in the homework, we took 360 degrees and we divided by the number of sides to get the magnitude. Here it's giving you the magnitude, so if we divide by 72 degrees, we get 5, which is the number of sides, or the number of times it can land on top of itself. So pentagon. 16, find the image of point D under translation by the vector -7, 2. So just take these original points, and we're going to subtract 7, add 2. 3 minus 7, and 4 plus 2, -4, 6. And it's not there. So there's an error on the answer key. So choose choice E, which is -4, 6. Yep, that works. 17, find the image of point Y after a dilation centered at the origin with a scale factor of -3. With this scale factor, you multiply that by the point, so it would be -7 times 3, -3, sorry, and 4 times -3. I don't know why the scale factor is negative, but I guess it is. 21, -12. B. And you can only use a multiplication trick when it's centered at the origin, so be careful of that. 18 says there's a trapezoid with these 4 points. Find the coordinates of the image of n along the translation vector -7, 9. So even though there's a trapezoid here, we're just focusing on point n, and we're going to take these points, 5 minus 7 and 9 minus 3 is -2, 6. A. This is another one that wasn't on the notes, but an easy problem. I'll explain it really quickly. It says a triangle is reflected in 2 parallel lines that are 2 centimeters apart. So I'm drawing the 2 parallel lines. Here they are. These parallel lines are 2 centimeters apart. And the triangle is reflected over both of them. So here's my triangle. I'm just drawing a right triangle. If I reflected over the first line, it would land right here. If I reflected again, it would land right here. So if we pretended that this middle one isn't there, this creates a translation. It's sliding from one place to the other. And the distance is double the distance in between the parallel lines. So 2 centimeters times 2 would give you the distance, 4 centimeters. So it's a translation 4 centimeters to the right. And then number 20, which of the following best describes the symmetry of the figure below? They give us different options here. If you sliced it this way, it would slice exactly in half. You could also slice it like this, and it would be sliced exactly in half. So there's 2 planes of symmetry there, and then axis symmetry, if you rotated it around this axis, it would land on top of itself at 180 degrees. It doesn't have to go all the way around to land on top of itself. So it is actually D, all 3. And that's it. So I'm going to stop the recording.